Hello, everyone, and welcome to my class. Today we will be learning about functions again. So let me share my screen, and if you can see my screen, say yes. If you cannot, say no in the chat. So let me know if you can see my screen right now. Okay, yes, very good. So today will be our 7th class on functions. So let's review our schedule. First, we're going to do a review of last class, which were one-to-one functions, and then we're going to learn a little bit about inverse functions, and then we're going to tackle some problems later. So let's review the definition of a one-to-one function. So the definition of a one-to-one function is a function is one-to-one if whenever x1 does not equal to x2 and the f of x1 does not equal to x2. So basically what this is saying is that every x only corresponds with one y. Now I know that sometimes you can have things like this, right? Where one y corresponds with two x's, right? And if you want a one-to-one function, then it cannot do this. So this condition also says that this also says f of x1 is equal to f of x2, then x1 should be equal to x2. And this is how we're going to verify if it is a one-to-one function. All right, so the main key point here is that this is our key point. Okay, every x corresponds with only one y. All right, so that is our main key point here. So are there any questions about the definition of this? Any questions? All right, if there are no questions, if you do have any questions, I'm explaining this. All right, wait. Okay, I'll go back to the slide in case you need to take notes. So I'll go back here. All right, so the main key points you want to take here is this, these conditions, and this. All right, these are the two key points. All right, and how do we test if a function is one-to-one? So we know the vertical line test, right? If you want to test a function, we use the vertical line test. So something like this would not be a function, right? So basically the vertical line test, we're going to draw an infinite amount of vertical lines. And if any of these vertical lines connect with 2 points, then it is not a function. Why? Because a function states that there cannot be an x value that corresponds with two y's. All right, so that's not possible. Now, let me introduce the horizontal line test and this test if it is a one-to-one function. So something like a parabola, that is obviously not a one-to-one function, right? Because every x does not correspond to only one y. So the horizontal line test is when you draw horizontal lines, and if any of them connect with 2 points, then it is not a one-to-one function. So some basic one-to-one functions are like x cubed or just y equal to x. That's a linear function. So the main key point is that every x corresponds with only one y. So are there any questions on this slide? Any questions? If there are no questions, then I'll move on. Okay. So let's look at how we prove something is not one-to-one. So obviously I just showed you that a parabola does not pass the horizontal line test, right? It's not a one-to-one function. So how do I show that f of x equal to x squared is not one-to-one? But you cannot use your graph, right? We cannot use a graph to show that. We cannot use the horizontal line test to that. So how do we prove that f of x equal to x2, x to the second power is not one-to-one? So whenever you're proving something is not true in mathematics, a very common way to do that is you can prove using a counter example, right? So this is our solution. So our solution, so for f of x equal to x2, f of 1, what does that equal? That equals to 1 squared, right? However, we can also see that f of negative 1 is also equal to 1 squared, right? Because of this. And let me remind you of those conditions earlier. So when x1 does not equal to x2, then f of x1 also does not have to equal to f of x2, and that contradicts this condition. So that is why for x1 equal to 1 does not equal to x2 equal to negative 1, f of x1 is equal to f of x2. And this is a counterexample. This is a counterexample, and this is how we use that. We can use 2 and negative 2, right? So 2 squared is also equal to negative 2 squared. You can use any counterexample you want. Just that's how you use a counterexample to contradict this. Are there any questions about this example? If there are no questions, then I will continue. So let's show that some of these examples are one-to-one. For example, very common one-to-one graph, x cubed. So how do you prove this? First, let me walk you through this first example, then I'll leave the others for you to do. So remember that condition earlier. If f of x1 is equal to f of x2, then x1 has to be equal to x1 has to be equal to x2. So basically, we're just gonna use that. So this is our proof here. If f of x1 is equal to f of x2, then x1 has to be equal to x2, right? That's what we're finding out. And we know that f of x equals to x cubed, right? So if f of x1 is equal to f of x2, then we're just going to plug x1 and x2 in, then x1 cubed should be equal to x2 cubed. And if you look at this, all right, you can take the cube root of this. We take the cube root of this, keep the equality, then we get that x1 does indeed equal to x2, and therefore we get the conclusion that f is therefore one-to-one. Right, and I don't like writing out one-to-one those words. It's very lazy, you know. So we just use the simple 1-to-1, right? That's how you show it's 1-to-1. Okay, so any examples? I mean, any questions on this example? It was a pretty easy example. And if you have any questions, please do let me know in the chat. And if you need me to pause for notes, then I will do that for you. Right. So, and also please do these examples in your notebooks. They are very helpful in understanding. Right. So let's do our next example, and I'm going to give you some time to do this one. Okay. I'm going to give you some time to finish this example, and I'll give you about a couple minutes or so if you need that much time. Okay, and I'll check back in a few minutes to see if you've solved the problem. So basically, I'm just gonna mute, and then I'm gonna put this question up, and please put your answers in the chat box. All right. All right. So, are there any answers yet? Okay. If there are no answers, then I will walk you through this. Okay. Hold on. How do I get rid of this? All right. So, show that f of x equal to 2x minus 1 over 3 plus x is 1-to-1, right? So let's use the same method we did earlier, right? So our proof. Hold on. This is our proof. If f of x1 is equal to f of x2, we just need to prove that x1 equal to x2, right? And if f of x1 equal to f of x2, we just need to plug that in. So 2x1 minus 1 over 3 plus x1 should be equal to 2x2 minus 1 over 3 plus x2. All right, so that's how we do this. Okay, and then, okay, we just cross multiply, right? We cross multiply. Okay, we multiply those two, and then we can just simplify and see if x1 does indeed equal to x2. So let's do that. And minus 1 times 3 plus x. Hold on. Why do I keep doing this? 2 plus x. So basically, we're just multiplying here. And then 2x1 minus 1 is equal to 3 plus x2. And if you simplify it all out, then you should get 7x1 is equal to 7x2. So therefore, we get x1 is equal to x2. So then we reach the conclusion that f is indeed 1-to-1. All right. So are there any questions about how I did this? And the following questions will be done in similar fashion. So just to give you more examples. All right. So any questions? Oh, don't switch yet. Okay. I'll go back. All right. I'll go back and basically we just need to clear two conditions. Well, only one actually. It's if statement right here. We just need to clear this condition and then it's 1-to-1. If f of x1 is equal to f of x2, after that step is another step where we need to plug x1 and x2 into this function and set them equal, right? Because that's what f of x1 is equal to f of x2. That's what it tells us. And then we just need to solve this equation to see if x1 does really equal to x2. And once we get to this, then we can reach the conclusion that f is 1-to-1. All right. No questions? All right. So I think this is our last example on 1-to-1 functions. All right, so show that f of x is equal to x squared, where x is less than or equal to 0 is 1-to-1. Now, we know that a parabola x squared or x4 or whatever, something that has a multiplicity of an even number is because it's always going to be like in form of a parabola. This is probably like x to the 6th or something. It's not going to be in the shape of a parabola. So no matter how we do it, as long as you have an even power here, that's not going to be 1-to-1. But what about only one side? If it's only less than or equal to 0, then this is a 1-to-1 function, right? Because it's actually from left to right, it's decreasing, right? And decreasing functions are 1-to-1. All right, so how do we show this? So actually, this is a quite difficult one. So let me, it's quite hard to grasp, but once I explain it, it should be better. So our proof, and the key here is this condition. All right, without this condition, it would not be 1-to-1. So, and also we're going to have to review a bit of absolute value here. So let's do that. First, let's set up the condition. If x1 equal to f of x2, then we get x1 squared is equal to x2 squared, all right? Because we just plug that into the f of x, all right? Because f of x1 is equal to x1 squared, and f of x2 is equal to x2 squared, and if they're equal, then we can set this equal to. All right, so how do you get rid of a square root? So basically, we just square root it. But then there's a catch, right? We square root x squared, what would this equal? It would equal absolute value of x1 is equal to absolute value of x2. All right. So why is this? All right. Because, all right, actually, this is a key point in algebra. So you must know this if you're going to learn algebra well enough. All right. So a common mistake here is if you have the square root of x squared, it's not equal to x or plus minus x. It's equal to absolute value of x. If you don't trust me, you can consult Google. It's a very, very reliable source. I can trust Google. So reliable. It is true. I rely on it a lot of times. Probably shouldn't do that, but it's cool. Anyways, so let's look at our what we're going to review. If we have the absolute value of two things and they're equal, how are we going to go about this? So let me bring up the absolute value. Remember this, all right? So the absolute value of x equals two things. The absolute value of x can be equal to x if x is greater than or equal to 0, or negative x if x is less than or equal to 0, all right? So let's not include equal to. It's just going to be greater than or less than, all right? So these are the two conditions. Now look at this condition right here. X is less than or equal to 0. That means that basically what we're doing here is negative x1 is equal to negative x2, right? Because they're less than or equal to 0, and if it's going to be equal to f, the value of x is going to be equal to negative x if x is less than 0, and x is less than or equal to 0 qualifies. So now we know obviously x1 is equal to x2, and we've cleared the condition, so we reach the conclusion that f is 1-to-1. All right. Any questions? If there are no questions, then I will continue. Okay. So let's look at the domain and range of 1-to-1 functions. All right, and this is going to lead us to how we look at inverse functions. All right. So the domain and range of 1-to-1 functions. You know that only one y or only one x in a 1-to-1 function corresponds to only one y. All right. So let's see here. Okay. So if we make this, let's draw a graph of a, not only draw a graph of a function here, and we know that there is this function here. Okay, so how about this? You make it like this, right? This is an increasing function, right? It's an increasing function, right? So let's say this is C and D, right? Because that is the range of this function. That's the range, C to D. And this is A to B. That's the domain of this function. And since every x corresponds to only one y, then if there's an x and A to B right here, okay, then there's going to be a y here, right? Every y only has one x corresponding to it, right? That's what is 1-to-1 function is, right? So this is our little graph of a 1-to-1 function, and this should deepen your understanding about 1-to-1 functions, right? So A to B is the domain of f. What did I just do? Take a screenshot? Okay. And C to D is the range of f. So in F, so in F, an x in the domain A to B corresponds to only one y in C to D. All right. Now, the inverse function. The inverse function is the exact opposite. The domain instead is C to D, and the range instead is A to B. So now this is our introduction to inverse functions. All right, let me give you the definition of an inverse function. All right. And so basically it's going to have the domain and the range are switched. All right. The domain and the range are switched for these two functions. All right. So that's the inverse function. You switch the domain and the range. So let's say you have a function like this, right? Then its inverse function is going to be this, right? You have an exponential and a logarithmic function, all right? The domain and the range are going to be switched like that, all right? That's how we graph inverse functions. We're just going to reflect it over a line. Okay, so basically, I'm just going to touch up on inverse functions today. I'm not going to go too deep. So, definition for a one-to-one function, y equal to f of x with domain a to b and range c to d, we define its inverse function inverse function we define its inverse function, which is called x equal to f of -1 of y, right? With domain c to d and range a to b. So basically, we're switching the x and the y. F is a to b to c to d, right? Its inverse is going to be c to d to a to b. So instead of y equal to f of x, we're going to get x equal to f -1 to y. All right, so that's how we're going to find an inverse. All right, so let me explain this. The example. So if we were to find the inverse of this function, 2x minus 1 over 3, we're going to set y equal to 2x minus 1. That's the key here, right? Setting y equal to 2x minus 1 over 3, then we're going to solve for x. It's going to be x equal to f -1 of y. So if you solve for f, then we're going to 3y equal to 2x minus 1. And then what we get here is going to be x equal to 3y plus 1 over 2, right? And that equal to the f inverse of y. Okay, so the inverse of f of x is equal to 3x plus 1 over 2. All right, so that is how we find the inverse. Because the domain and the range are switched, then we also have to switch the x and the y, right? So are there any questions about this? Do you need me to go back so you can take notes or anything? If you don't need me to go back then to take notes, then I will continue. Okay? So, number 2, f of x is equal to x squared. X is less than or equal to 0, find its inverse. All right, so I'll give you a few moments to do this. Okay, use the technique here. Just set y equal to that function and find solve for x. All right, so I'll mute and give you a few seconds to work. I mean, not a few seconds, a few minutes to work. And put your answer in the chat box if you have one. All right, I'll now walk you through this. So I hope you have all done this problem in your notebooks. Okay, so let's walk you through this problem. So f of x is equal to x squared, where x is less than or equal to 0. Now find its inverse. So what we need to do here is we need to set this equal to y. So y equal to x squared. Now solve for x. And again, this condition is very important. So to simplify this, we need to take the square root of both sides. And again, we get left with the absolute value of x. And we know that x is less than or equal to 0, right? So we know that the absolute square root of y is equal to negative x. All right, so x should be equal to negative square root of y. All right, so the f inverse of y is equal to negative square root of y. Right, so the inverse of x is equal to negative square root of x. All right, so that is our inverse function of f equal to x squared, where x is less than or equal to 0. So now let's continue. This is another problem I want you to do. All right. So are there any questions about the last problem? Any questions? If there are no questions, then I will continue to let you solve this problem. Okay, I'll give you around a few minutes to do this, because inverse functions are pretty hard to grasp. So I'll mute myself and let you guys work for a couple minutes. And if you have any answers, please put them in the chat box, and I'll go back in a couple minutes to check. All right, so here's the problem. All right, so I'll now walk you through this problem. Okay, so our again solution is we need to set. Okay, let's set set f of x is equal to 2x minus 1 over 3 plus x equal to y. All right, and then we're going to solve for x. All right, we're going to solve for x. So if we set this to equal to 2x minus 1 over 3 plus x, then we can just do that, right? So basically we can just cross multiply, right? We get 3y plus xy is equal to 2x minus 1. And this is like a literal equation, right? We now need to solve this. Okay, so let me remind you how to solve these literal equations. Basically, you see these two terms that multiply to x. We need to get that and factor that out, and then we can isolate x, right? So let's do that, and let's move some terms over here. So 3y plus 1 equal to 2x minus xy. Now, if we just factor this out, right? Just factor this out, then x equals 2 minus y. Okay, then we get x is equal to 3y plus 1 over 2 minus y. Then our conclusion, the f inverse of x is equal to 3x plus 1 over 2 minus y. I mean x. All right, so that's the inverse. Okay, so that is how we solve that. A little review of how to solve literal equations where you have two variables, right? Two variables. Okay, so that's a pretty good review, right? So are there any questions about this so far? Any questions? All right, no questions, then I'll give you this last problem. All right, this last problem. Okay, this is our last problem here. So this is maybe the most difficult one you've done so far, but it's pretty easy once I explain it. So I'll give you a bit more time to do this one. So here's the problem. All right, and please put any answers in the chat box. All right, so here's the problem. I'll check back in a couple minutes. All right, I'll now walk you through this problem. So basically, you set y again. You set y equal to x squared minus 4x plus 7, then solve for x. So when you do that, we can do basically we can do this, right? We can do if we do this, then we can use complete square, okay? Then this would be equal to x minus 2 squared plus 3, right? Then what we need to do is we need to isolate y minus 3 on this side. I mean, we get the absolute value of x minus 2 because we square root, right? We get this, okay? And because, oh, I forgot to include a condition here. So how about we do this? X is less than or equal to 2. All right. Let's say x is less than or equal to 2. All right. So that's our condition here. Then it'd be the result. Square root of y minus 3 would be equal to negative x minus 2, which would be 2 minus x, right? So 2 minus x, then we get x equal to 2 minus square root of y minus 3. So then we get our conclusion. F inverse of x is equal to 2 minus square root of x minus 3. Now, there could have been another way you did this, which is the quadratic formula, and that is also an option. So there are two main methods to do this. And also, I would like to make a big announcement to everybody now, and that is that after this class, we're going to have 2 weeks of break. All right, so let's do that. Okay, wait, I'll go back. So it's just solving a quadratic. It's not that hard, all right? But the main point is to get this absolute value, right? So anyways, the big announcement is that after our 2 weeks of break, I went winter break, right? So Christmas, whatever you do, okay, spend time with family, go play somewhere. I'm just gonna stay home and hibernate. But anyways, after winter break, that is going to be the start of a new semester. And after that semester, I am going to reteach all of my material starting from basic algebra. All right. So my old students, you will no longer learn from me anymore because I'm reteaching all this material. Because if I teach any more into logarithm, it's going to be too hard for anybody to understand, which is going to be a problem. So I'm going to reteach all this algebra, basic algebra stuff, like literally x plus 5 is equal to 7. What is x? Because that I'm gonna reteach it, try to improve my understanding of that too. Because reteaching stuff improves your understanding of everything, right? So this will be my last class with you think you need to relearn some things, Carney. So you don't know how to do x plus 5 equal to 7. Good for you, Carney. Great. So I guess Carney won't be leaving anytime soon. And oh, and Jenny will not be leaving too. Okay, so I guess some old students will be staying, but yeah. All right, but it's gonna be quite easy soon, right? Because I'm starting from 7th grade basic algebra. Because I'm reteaching the course, right? So I'm gonna also try to make these classes better and more detailed, all right? And I'm gonna actually go online and look up a 7th grade calculus because curriculum because I don't remember what I got in 7th grade. So anyways, that is the end of our class. So I hope you learned something from this class. And bye. Geometry. Geometry, well, school geometry is kind of weird, right? You know, currently, geometry, you have to learn about angles and stuff. You have to memorize properties of quadrilaterals and proofs, which are kind of sad. And unlike algebra problems, which I can make up myself, like anybody can make up an algebra problem, right? You just have to know how to solve it. Except geometry problems, I had to take them from an actual textbook, which is kind of pretty sad. And I don't want to do that. And of course, there are also like Math Olympiad geometry problems, but those are kind of hard, right? And like AMC, those geometry problems are kind of hard. So geometry one problems, you don't have to worry about yet. So, anyways, that is the end of our class. So I'll pause the recording now, and thank you everyone for listening.